Hello, and welcome back to the continuing lecture in investment analysis, Finance 300. Now, we've been talking about the Burton-Malkiel's theorem in bond pricing, bond price relationships, right? Burton-Malkiel is actually a very influential and very important, one of the very important economists, because not only because of his work in the price sensitivity, interest rate sensitivity of the bond price, but one of his famous book is a monumental book in finance called Random Walk Down Wall Street. A Random Walk Down Wall Street. Now, the term random walk actually is something you would encounter very often in as you move up to a more advanced course, more advanced courses in finance, and especially in econometrics and in data science, especially. Now, what does random walk mean? Random walk means the same thing as Brownian motion. What is Brownian motion? Brownian motion refers to the movement of the gas particles, right? Gas particles, which are basically molecules, right? Gas molecules. Is there any pattern? Is there any deterministic pattern or trend in the movement of the gas particles? There's in gas particles have no particular pattern. They just move randomly, right? So in physics, it's called Brownian motion, which means it just moves randomly. There's no pattern. It's crazy. It just and in econometrics or in data science, Brownian motion is called random walk, because random walk is like it comes from the analogy of a drunken man walking down. A drunken man walking down the street has no pattern. He's zigzagging, meandering. There's no way to predict where his next step will take him, right? So that's exactly what the random walk means, meaning in the stock market, especially in the short run, the price movement is really, really, random, right? It's random walk. It's like Brownian motion. But is there any? But then it seems like you can't explain, random walk. There's no, but still, there's a math that can explain the random walk, and of course, it's still has certain variance, mean variance, and the variance is with variance increases with square root of time and so on, the type of but anyway, think about it. If the stock market is random walk in the short run, there is no point in analyzing security analysis. There's no point in security analysis. It sounds like Yes, but it's random walk only in the short run. In the long run, there is always a pattern, a deterministic pattern. Um, and uh, hence, comes the modern portfolio theory. And in modern portfolio, obviously, uh, everything has to do with, mean and variance. The modern portfolio theory is basically, about the mean reverting trend, and the variance built around it. Anyway, that takes, that has already taken, 6 minutes of our time. So I'm not gonna go further on Mulkill. Mulkill, Burton, but the thing is, a random walk down the road, down Wall Street. When I was a graduate student, I I knew that book, although I didn't, read it, but I knew what it was about. What's important is, how to model random walk, right? How to model random walk rather than reading the book. But at the time, I didn't know. I didn't know it was Burton Malkiel who wrote it. It's just a famous book, but I didn't know it was Burton Malkiel at the time. But anyway, the point is, he's five, theorem, right? We talked about, up to theorem number 3 in the last video, right? Now, interest rate, Malkiel's number 4, theorem number 4, says, the sensitivity. What does this mean? Change in bond price over change in bond price over change in interest rate, right? Increases at decreasing rate as maturity increases, right? What does that mean? First of all, change in, what does this mean? Change in bond price with respect to change in interest rate. This is exactly the interest rate sensitivity of the bond price, right? What does this mean? How you remember how much did the bond price change when interest rate changed by, let's say, 1%, right? Of course, this relationship, in other words, this ratio will be negative, right? You understand? This ratio will have to be negative because they move in opposite direction. Make sense? They move in opposite direction, right? So this, think about it. Change in interest rate, let's say it went up 1%. And how much did the price move? The price will go down if interest rate goes up, right? But then, for 1% change in interest rate, how much did the price change? And the price change would be in dollars, right? Of course, we can express it in percentage, right? So that's the sensitivity, right? And this increases the sensitivity, price sensitivity, interest rate sensitivity of the bond price increases at decreasing rate as maturity goes up. So the longer the maturity, right, the sensitivity, sensitivity will go up, but at a decreasing rate, right? It is most sensitive, right, for price and for change in interest rate. The price is responding most sensitively when with shorter time horizon rather than longer time horizon, right? So interest rate risk is less than proportional to maturity. Yes, it's not exactly directly proportional. So that means it's not linear, but a convex curve or exponential function. Exponential function. So that's Malkiel's theorem number 4, and we know from this graph we've seen that. So for example, A and B, bond A and bond B have same coupon rate, and they both have the same yield to maturity, but bond A has 5-year, bond B has 30-year maturity, and we have seen A is, responding less sensitively than B, and that's already given. But then the sensitivity increases at a decreasing rate with maturity. The longer, so to explain that, we might need to come to this, use this, table later. But let me finish up here. So out of 5, right? Out of 5 theorems, actually, there are 6, and actually Malkiel, 6 out of 6 theorems, 5 of them is Burton-Malkiel's theorem. The 6th one is not Malkiel. It's it's called generally non-Malkiel, but it was actually Homo and Leibowitz that came up with the 6th theorem. But anyway, let's quickly take a look at the 5th Malkiel's theorem number 5. Interest rate risk is inversely related to coupon rate. Of course, interest rate risk is basically price and interest rates are inversely related. That's Malkiel number 1, theorem number 1. Theorem 5 says interest rate risk. Interest rate risk is also called price risk, maturity risk. And interest rate risk is inversely related to coupon rate. Yeah, think about it. Price of low coupon bonds are more sensitive to interest rate changes than price of high coupon bonds. And I mean, logically, if you think logically, you can also come to this conclusion, because the higher the coupon rate, right? Higher the coupon rate, you're getting, your cash flow. Your cash flow is higher. So even if there is an interest rate risk, interest rate suddenly goes up, and everything is valued, everything is, discounted more, so valued, lower. But obviously with more cash flow, right? 10 out of 10, 10 cases out of 10, your bond will lose value less because, the cash flow is higher, right? So the higher the coupon rate, the lower the interest rate risk, right? The lower the coupon rate, and this is also related to the reinvestment rate risk as well. That's Malkiel's theorem number 5, and then next one is Interest rate sensitivity, right? You should understand, already, what this means. Um, it means, price change in price with regard to change in interest rate, right? The ratio between the two. I mean, the ratio between the two represents, obviously, it captures the sensitivity. I mean, if this ratio is, the greater this ratio, the greater the sensitivity. And this ratio is always a negative number because they move in opposite direction, right? So interest rate sensitivity is inversely related to the bond's current yield to maturity. And this is non-molecule, this is, Homer and Lebowitz, almost, 10 years apart. Yes, yield to maturity, the lower the yield to maturity, right? Lower the yield to maturity, that means, the higher the sensitivity, right? Or, vice versa. So let's take a look at, the rest of it. So here's, suppose you have 8% annual coupon bonds, right? That's coupon rate of, yeah. Coupon rate, I see coupon 8%. And think about it. The story will be, suppose what if, y is, what if, y. So yield to maturity, in other words, y, right? Bond yield. If bonds yield is, I will put it here. I think I would rather put it. And if it is 8%, it will be a, a par value bond, right? Regardless of, maturity, 1 year or 10 years or 20 years, it will always be par value. But if the yield to maturity is 9%, in other words, there are three possibilities, right? This is, less than, equal to, or greater than yield to maturity, right? This time, let's say yield to maturity is greater than, right? So that means, yield to maturity is greater than coupon. And then, of course, then in that case, it's going to be, a discount bond. So it's going to be a discount bond. But, the longer the maturity, the drop in, change in price, right? Of course, the shorter the maturity, the drop in price is the smallest, right? And the longer the maturity, right, drop in price increases, right? Makes sense? So this is what? Molekil's, actually, this is Molekil's theorem number 5, right? Interest rate risk is inversely related to coupon. Oh, no, actually, inversely related to the bond's current yield to maturity, right? It's Homo and Lebowitz, right? It's, theorem number 6, Homer and Lebowitz, right? So, and then what if it was a zero coupon bond? Of course, when there is no coupon, I mean, at least we had coupon, right? We already know this is Moltkill's, number 5, I guess, because, number 5 is what? Interest rate risk is inversely related to the coupon rate. So with higher coupon, right? This is without coupon. And when there is no coupon, when yield is greater than the coupon rate, so it will be a discount bond. Look at how much it falls, right? Of course, they all fall, right? But at 1 year, bond has the same drop, same rate of change, right? But 10 years drops way more, right? 20 years drops way more than coupon bond. So this is Moltkill's theorem 5. Okay, obviously without coupon, change in price is much greater than change in price with coupon. Okay, makes sense. Now, so before we move on, we have to remember, I said change in price over change in interest rate. This is the sensitivity, right? But doesn't it remind you of something, right? What does it remind you of? Do you remember what elasticity is? Elasticity from microeconomics. What is elasticity? Elasticity is price elasticity of demand, right? Price elasticity of demand. Just like, interest rate elasticity of bond price. Okay, so I mean, there are two types of elasticities in microeconomics. One is demand price elasticity of demand and income elasticity of demand. In other words, how the quantity demanded, right? What is elasticity? Elasticity is basically what? Percentage change in quantity demanded. This is hard to write. Over price change, percentage change in price. Now think about it. This ratio will also come out as negative because price and demand moves in opposite direction. When price goes up, demand goes down, right? When price goes down, demand goes up. So this number is bound to be a negative number. But think about it. What is percentage change? Percentage change is actually, if you think about it, change in quantity over quantity, right? That's percentage change in quantity, and change in price over price, that's percentage, isn't it right? So think about it. If the price went up from $100 to $120, the change in price is 20%. How do you know it is 20%? Because it's 20, the change, right? $20 divided by original price, $100. Make sense? Uh, so if you rewrite it, you can rewrite it as Q2 minus Q1, or, okay, let me do it this way. It's hard to write. Q0. Okay, let me change that to Q1, right? So Q0 is the old demand, quantity demanded. Q1 is the new quantity demanded. And then that must be divided by Q0, right? And then just like that, it is P1 minus P0 over P0. Okay. Now that simply then, we can rewrite it as, I mean, that's how it is rewritten, right? But changing Q over Q0, and we can rewrite it as, because you are dividing this by fraction, right? So when you are dividing something by fraction, it's the same thing as multiplying by the reciprocal. So it would be like P0 over change in P, right? And it's the same thing. We can rewrite it as, we can switch simply because it's, numerator by numerator, denominator by denominator. So we can simply switch, numerators, denominators with, denominator with, denominators. Denominator, one denominator by another. Ah, come on, it's so hard to write. Actually, I'm drawing, right, with mouse, So it's going to be like P over Q. Okay, so this is elasticity, but actually, the sensitivity part, that percentage, the sensitivity part is already captured by this term, right? Ay, ay, ay. It's already captured by this term. It's so hard to write, but because what is sensitivity? When something changes by 1%, or sensitivity. So when something changes by, I'll just write, just sensitive, because it's too long to write sensitivity. Sensitivity. Okay. When one variable changes, x variable changes by x%, and then how much y variable changes, that ratio between the two change, the ratio between change in y over, to change in x, that's basically, that captures the sensitivity. So exactly the same, you know, um, rationale, same reasoning behind it. In this case, it's the sensitivity of quantity with respect to change in price, but in this case, it's the sensitivity of bond price with respect to change in um, interest rate. So this will be a very crucial concept, critical concept in the topics that we are, that we're going to be exploring in the next videos. Okay, in the upcoming videos. All right. So our time is up. So I'll have to stop recording, and we'll see you in the next video. Take care now.